Alright, so this one is about I/O. So, and I gotta say, I'm extremely excited for this. I haven't really fully thought through what exactly I want to talk about, but with this being something that I have found to be deeply fascinating in Haskell, I'm sure it'll just come right out of me. So, what's a super cool point to know about Haskell is that, well, Haskell started as a research language, and one of the most defining factors of it being a research language was that it was impossible to do I/O. You could create a lot of heat on your computer and create no side effects. And so what is a side effect? Well, a side effect, for example, is put string line, and how I say, hey, it says hey here. But if I look at the type of put string line, it's just IO tuple, or empty tuple, or unit. And so that's what's meant by a side effect, is that we bring back a tuple into our execution. I could operate on this tuple. I'm not sure what I would do with it. Maybe I could say, this is not going to be very useful, but I could say print. And this is going to print out that tuple. But it's not going to print out hey. Well, it will print out hey, but it will not give me back hay to operate on. Not even the kind for horses. And so that's what a side effect is, and that's what's meant by a side effect. And so Haskell used to not have any capability to do that. You could do a bunch of cool math in it, string and list manipulation, but you could not do any input or output. And the reason for this is because Haskell wants to be a pure language, and it is a pure language. But how, if it is a pure language, do you deal with something like I/O? And as I mentioned before, we had our function getLine, which we use in Hangman, and we saw that I can make this an impure function. I mean, I could be a robot and just make this a pure function. Just continually go, and say, giving it back E a billion times over. And then I've made this impure pipe into a pure, pipe. But that's not how the real world works. We don't know what to expect from our users, especially with web development. And we have a form for users. We have no idea what to expect from them. Even, for example, sometimes forms are just completely off, and it's like, I actually had a recent case, funny story, where, I was trying to fill out, I was trying to get a credit report, and funny story, my siblings will hate me for saying this, but they're not going to watch these videos anyways. None of them are programmers. Actually, one will, but whatever. I don't care. All of my siblings and I were named Augustine, and then our middle name was different. So my middle name is Galen. That's what I go by, and that actually caused me a problem when I tried to go through Borrowell, because they couldn't find my credit. Well, they found a credit report, but they were giving me questions that were clearly for one of my other siblings, and I didn't know which one it was. So my point here is chaos. The real world is chaos. Borrowell thought they had, these forms figured out, and they forgot to ask me. They only asked me my first and last name, and there's no way to differentiate between myself and my siblings. Further, I didn't have to put Augustine for my first name. I could have put blah, 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 and a couple random characters. I could have, had what the? Okay. Oh, that's because I'm doing something else. I could have put this for my name. And Borrowell needs to, or any program needs to be able to handle whatever type. Now, this is not at all, only a Haskell thing. This is a every program type thing. But that doesn't, there's no reason behind why the internals of the program should be so crazy and as crazy as the real world. We do not want the complexity and variability of our own programs to be as complicated as the real world. We are effectively trying to take a complex thing and make it a little bit simpler each and every single time. Kind of like a funnel I'm trying to draw out here. And you can hopefully imagine this cascading out, and we're trying to slowly groom it into a case that we can understand. And know, and we want to understand and know exactly what this case might be so that we can know how to handle such a case. And we cannot do that if the internals of our program are impure. So that's the whole reasoning behind purity, but also then that means that Haskell still has to deal with impurity. So that was the invention of monads, specifically I/O. I/O being the first monad. And now we haven't talked about what monads are. They are a type class, and we will spend more time on them. But that is the reasoning behind monads to begin with. And I can reference that being said by Simon Peyton Jones in the video, which I'll probably try and dig up and put in the description for this video. Definitely recommend watching that video as well. So as I was talking about with the hangman example, this is where we are going from crazy to not crazy. And I don't think this can even be summed up in this video alone. I guess what needs to be said here for now then is that we are only going to be dealing with and thinking about how to eliminate some of the chaos at this step. And yeah. So yeah. And we're not even really actually handling it in the way we need parsing to do that. But why do we need parsing then? Well, parsing always deals with a string. And so that is effectively what we are often faced with when we are doing I/O. And now, not really. A more accurate way to say that might be that we're always dealing with byte strings. Byte strings being, of course, if you're familiar with them, just sequences of ones and zeros that get turned into characters, and at that point we can parse those into real Haskell data types. And yeah, I don't think that spoils anything about parsing. I mean, we kind of need to know that anyways. So, but yeah. So let's look at how to get some of these chaotic strings, I suppose. I have here at the top, you can see that we're going to do some simple operations, do some quick web request. We're going to learn how to read a file, go over get line, and talk a bit more about buffers. Just we'll talk about buffers, and so I also want I want to address another part of theory in that so Haskell is not an imperative language. Imperative meaning that you execute a sequence of actions and they have some semi-chaotic effects on some global state. And so I/O has to be imperative. By definition, the only way that you could have an I/O that is not imperative is if you had literal control over the entire state of the entire world. You had control over not just the computers and the entire internet, but you had control over every interaction with such computers that, it doesn't need to be imperative. And I'm still kind of, unsure that would be true. That you could have declarative reasoning. I guess even then you would need to know everything about the state of the world at that point in time. And then once you know everything about and have information about the state of the world in that entire time, then you could have a declarative type thing. So there's probably a whole lot of jargon if you don't care. Apologies, but just want to clear that up about Haskell is not an imperative language. Haskell is functional, declarative, yada yada, not imperative. But we have to do imperative in this case. And so we are just doing the minimal amount of imperative actions. So, for example, we could still cause an issue for ourselves if let's say we have a function that, we have a function, one step in a function that deletes a file. Now, if we have another function which tries to read from that same file at that same path, then of course it's going to fail. I mean, that's just, I don't know what the solution is there. It's going to happen. The solution is better code. And Haskell can only stop you from doing so many mistakes. The GHC compiler is amazing for stopping you from making a number of mistakes in Haskell land. I mean, if you wanted to delete memory from the Haskell program, I suppose you just wouldn't pass such memory to another function. You're right. You wouldn't pass. You have some function which, let's say, takes an int and does I/O. And, if you wanted to delete that int, you would just, have the underscore wildcard so that you have no access to that int. And that would effectively be deleting it. But the reason that Haskell could stop you in this case is that, how do you reference it? How would you say read file from X? Assuming that X is what we would call this. If we instead did this and then tried to compile our code, it would say X is not in scope. I do not know where to find that memory. So, but of course, how would the GHC Haskell compiler do that if we're not in the comfortable land of Haskell with purity and beauty? But so yeah, that's a lot of talking. Do you guys have anything to say? Anything to add to that? All right, cool. So I'm just gonna delete that. And so the first thing we should start with is let's read a file. We're gonna just read a file, and then we are going to write the contents to another location. So I'm going to see what we have here. We have changelog.md. You know what? Let's do that. Let's check what's in there. Yeah, that looks cool. So we're going to have our function, and it is going to do I/O. We're not going to pass it any arguments. We're just going to do I/O inside of it. And so we need our handy dandy do. Yeah. Wow, I do have a lot of energy right now. So let's see. The first thing we should do is I am going to say that I forgot what function I need here. And so go back to Cabal REPL, and I am going to go to Google again, and I'm going to look at my function read file. And so there's a couple different variants of read file, just based on whether or not I could return it as a byte string. You know what? Let's do that. Yeah. Well, actually, no. I'm not going to do that. I'm just going to keep things simple, just for the sake of keeping this video short. All you really need to know is that we are there's a function pack, so we would do. You know what? No, I am going to do this. This is worth it. This is worth it. Data.byte string. So I can see that this is from the module data.byte string. So I'm going to import data.byte string. And come to think of it, I'm going to need to do some of this stuff anyways for web requests. So why not? I also know, just by memory, there's really not that many libraries I actually have to use, I suppose. I'm going to want to use, okay. I'm going to import this qualified just so we can see where I'm using it. And then data.byte string dot encoding. So this should compile. Oh, and I need to go back to main, import IO. Is that going to cause an issue? Oh, and I'm going to need to add to my Cabal file. I will do a more in-depth explanation of Cabal at some point. But I'm just getting the byte string package. It is not a part of base or prelude, so I'm going to want to do that, and then restart my Cabal. By the way, I've heard some people say that Cabal sucks, and I've never actually had a problem with it. And wouldn't that be funny if this was a problem? But I've never actually had a problem with it. I will do a more in-depth explanation of it, and I really would like to know if you are someone that... Maybe I do... okay, what is it? Encode UTF-8, decode UTF-8. Data.text. Oh, right. So I'm just going to use my Emacs to open up a couple different buffers here, and I am looking for data.text.encoding, which has the decode UTF-8 function. And so decode UTF-8. Oh, wait a minute. Let me think here. I don't think it's a big deal. I'm realizing, I guess... Oh, wait a minute. I am just fooling myself. There is nothing wrong. We are all good. And I'm not even just saying that to you guys so that you'd think I didn't have a mistake there. I did have a mental blip, but yeah. Easy to overcome one, I suppose. So, yeah. So, first thing I'm going to do is I'm going to say bs.read file, and well, what do I want to do here? bs.read file. What were the type of that? Actually, it would be available in my REPL. If I do type of read file, would it be there? Ooh, that's a different one. But I'm using this one, so I can see that it takes a file path. File path is just a string. It's just a type synonym for a string. So, and it is going to read from the root of my project. So that would mean that the string that I need to give it is changelog.md. I can test this by saying call changelog, and then I'm going to print changelog. And actually, well, I could use put string line here, and oh wait, no, I need to use print because it is a byte string. So if I call func, what did I do? Knew it. Did I know it? Yes, I did. Cool. So that is the contents of our byte string there. And you might be wondering, where are the ones and zeros? So the show instance of byte string is to convert it. I believe, well, it must be. I'm assuming this just based on what I'm seeing here. I don't know of any other possible explanation that a byte string gets converted to a string. Yes, this actually makes sense. What the REPL would be calling is print of the result of whatever function we called. So, you know what, we're literally calling print here. derp. So, I am calling print on changelog, and so print is going to convert changelog to a string and then print it. And so I guess the show instance for byte string is to, well, convert it to a string rather than, show the literal sequence of ones and zeros. So now, if let's say I want to use a different function, so I could write this directly to file. And I don't need to do anything here, but I am just going to, for the sake of fun, use the built-in function, or sorry, the prelude function of write file. And this is expecting a string. So I have a byte string here, and I want to turn it to a string so that I can write it to a file. Or in another way, I want to make it fit this function so that I can use this function. So how I'm going to do this is I'm going to say write file, and I can write it in this in the base of the IO monad or the do statement, because it is going, when it's fully applied, and I'm assuming I'd always wanted to make it fully applied, it's going to be IO. So if I do write file, some file path .txt, and then I want to first convert this to text, and then I'm going to convert it to a string. So text is effectively the exact same thing as string. A lot of people are even asking, why was string a part of the base library? And it's really just out of convention. Text is a lot more efficient for how it's actually encoded, or how it's implemented. So if I say Oh, and I'm realizing that I called this that, so I'm going to call it T. So from the T package, I'm going to use t.decode UTF-8 of changelog. This is going to give me a text, and I can see this. Well, so yeah, I'm gonna try and show you guys this quick. It's gonna fail because it's gonna say this is a data.text, or this is a text rather. You don't really even need to see that. And so to convert back and forth from string to text is very easy. We have a function, which I believe is in. Oh, you know what? It wouldn't be. I'm going to need to import data.text, and I'm going to also call it T. I'm going to make it qualified. I don't have to make it qualified to name it, but otherwise it might cause some annoyances in terms of the functions being the same name. So I'm going to say t.unpack. T.unpack turns it into a string. I'm also using a new thing here. This is a chaining function, and so I'm not using it here because, well, could I do this? This might make things a little bit simpler. I hope. Yeah. So what I'm doing here is I am chaining functions. And then the end result of that chained function is writing the file. So I start by having a changelog. I decode it into text. I unpack that text. And then that becomes a result, kind of like right here, to write file. And I've put the brackets around write file just so that basically how I think of it, so that the compiler can read the statement of being a chain. Otherwise, it will get a little confused, I believe. I'm not 100% sure about this, but it should get confused if I recall. Oh, awesome, cool. All right, that is even better. And so I guess it didn't. Awesome. And the thing is with this chain is that all of these are expecting one argument more, and that's going to be the result from the previous. And it's just going to keep passing its input to the next function. Its output to the next function to be that function's input. So we have just written some, well, if we call this function, I don't think we saved it. We didn't recompile it. So now it's going to do nothing. And if I look, we have some file path.txt. We cat some file path, and we have this. Sweet. I'm actually going to cut this off just because I'm realizing this is already at half an hour, and I am going to have the next video be about a little bit more in depth with buffers, expanding on what we've done here, and and then web requests. So yeah, thanks for watching this first video. Hope you're watching the next video right after this, but in case you're not, hope you enjoyed this part. I will say you don't have to watch the next video if you do not plan on doing any web requests or don't care to have a better understanding of what exactly we are doing here. But I want to explain what exactly we're doing here, because then you kind of start to see an equivalence between a number of different things, and it just simplifies input output for you. So yeah, I'll see you next time, and bon voyage, and have a good night, or a good morning, or whatever time of day or you know, whatever time of day it is for you. So, peace out.